Welcome to the Deep Dive. We're here to sift through the technical docs, the articles, the noise you send us, and pull out the key insights you can actually use. Today, we're diving deep, really deep, into a specific Salesforce feature. It's called PK chunking, and it's all about handling massive amounts of data.
Yeah, this one sounds super technical on the surface, maybe a bit dry. But trust me, if you've ever been stuck waiting hours for a data extract, only for it to crash right at the end, then PK chunking isn't dry at all. It's essential. It's about making those huge data queries actually work reliably.
Okay, so let's break down that name first, just to get everyone on the same page. PK chunking, two parts. First, PK.
Right, PK stands for primary key, simple enough. In Salesforce, that's your record ID, the unique ID field on every single
The
record.
unique identifier, got it.
Exactly. It's like the unique address for that specific bit of data in the whole system.
And then the chunking part,
Yeah.
which sounds pretty descriptive.
It is. Chunking just means taking a really big job and breaking it down, splitting it into smaller, more, manageable pieces or chunks.
So PK chunking means using those unique primary key IDs to break up enormous data queries into smaller bits.
Precisely. It uses the sort of sequential nature of those IDs to map out how to divide the workload.
Okay, let's set the stage then. Why is this even a thing? What's the problem PK chunking is trying to solve? Imagine you're dealing with, like, a ton of data.
Yeah, imagine you're a big company, right? You might have 30 million records, maybe 50 million, maybe even 100 million or more accounts, contacts, whatever. Now, say you need to pull all that data out, maybe for a migration project, or you need to load it into your data warehouse for analysis.
You'd probably try writing a big SQL query, right? Just select everything I need.
That's the natural instinct. But if you try to run one massive query to grab, say, 50 million records all at once, you're going to have bad time. Well, first, it'll take ages to run. But more critically, you'll likely smack right into Salesforce governor limits. The query will just time out, fail.
Because it's trying to do too much at once.
Exactly. The system has limits to protect performance for everyone. A single massive query consumes way too many resources, so it gets shut down.
Like trying to drink the ocean through a straw. The
Yeah.
system just says, nope.
That's a good way to put it. And so our mission today in this deep dive is to really unpack how PK chunking acts as this incredibly effective workaround, how it turns that risky, failure-prone process into something predictable and reliable.
Okay, perfect. That takes us nicely into our first main area, the why behind it, speed and reliability. So fundamentally, how does PK chunking achieve that reliability?
The core idea is ensuring predictable results. That's key, right? You need to know you got all the data. So when you enable chunking, you still submit your one big query. But behind the scenes, Salesforce doesn't run it as one job. It intelligently breaks it down.
Into those chunks we talked about.
Yes. It runs maybe dozens, maybe hundreds of smaller sequential queries based on ID ranges. Each one is fast and manageable.
I remember seeing a really good analogy for this in the source materials we looked at. The marathon one. Can you share that? It clicked for me.
Oh, yeah, the marathon analogy is great. So think about running a 42-kilometer marathon. The normal way, without chunking, is like having one single runner try to do the whole distance. They might get tired, they might get injured, they might just not finish, or finish really slowly.
High risk.
Very high risk. Now, PK chunking is like taking that same 40-kilometer distance, but dividing it up among 42 different relay runners. Each runner only has to do 1 kilometer.
Okay, so each runner does their small part quickly and easily.
Exactly. Each 1K segment is fast, low risk, almost guaranteed to finish, and when you add them all up, the whole marathon gets completed. Probably much faster and definitely more reliably than relying on that one exhausted runner.
That makes sense. It's distributing the load to guarantee completion.
That's the core principle. It swaps uncertainty for predictability.
So, for someone listening, maybe a data architect or a developer planning a big data job, when does this become absolutely necessary? Are there specific thresholds?
Yes, there are. The documentation is pretty clear on this. There are two main triggers where you really must consider using PK chunking. First, there's a hard number. If you are querying more than 10 million records in a single job.
10 million. Okay, that's a clear line.
It is. Once you hit that scale, trying it without chunking is basically asking for timeouts. The second trigger is more about experience. If your current bulk queries, even if they're under 10 million records, are just taking way too long, or worse, they're frequently timing out.
So even below 10 million if you're hitting performance walls or reliability issues.
Then PK chunking is your answer. It tackles that timeout problem directly, regardless of the exact record count, if the complexity is causing issues.
Got it. So 10 million records, it's a must. Below that, it's the go-to fix for slow or failing bulk jobs.
Right. It's both a safety net for huge volumes and an accelerator for troublesome queries, especially on objects that are known to be large or complex.
Okay, we understand the why. Let's get into the how. Section 2, the mechanism. How does this magic actually happen? You said the user submits one query.
Correct. And this is the really elegant part. You, the user, you submit your one big SQL query just like you normally would for a bulk job. You don't have to write 200 different queries if you have 50 million records.
Thank goodness.
Yeah. When you enable PK chunking, Salesforce automatically intercepts that query. It looks at the object you're querying, finds the lowest and highest relevant record IDs based on your query's where clause, and then it does the math.
The math to split it up.
Exactly. It calculates ranges of sequential IDs to create the chunks. So batch 1 might be records with IDs between, say, A and F, batch 2 might be G to M, batch 3 N to Z, and so on. Metaphorically speaking, of course.
Using the actual record ID.
Using the actual 18-character record IDs, it figures out those boundaries automatically.
Now, a quick technical point here. Salesforce IDs look sequential, but sometimes, especially in older orgs, records weren't necessarily created in a perfect ABC order based on time. Does the chunking rely on creation order, or is it smarter than that?
That's a really important clarification. No, it doesn't rely on creation time. It relies on the inherent lexicographical ordering of the ID strings themselves within the database index.
Oh, okay.
Salesforce performs efficient range scans on the index ID field. It finds the lowest ID that matches your criteria, queries up to a calculated boundary ID, then the next chunk starts right after that boundary. It doesn't matter if there are gaps or if IDs weren't created strictly sequentially in time.
So it's robust against weird ID sequences or fragmentation? That's good to know. It guarantees you won't miss records.
Precisely. Because Salesforce manages defining those start and end points for each chunk based on the actual ID index, it ensures every record matching your query is captured exactly once. No overlaps, no misses.
Okay, so Salesforce runs all these mini queries. What happens when they finish? Do I get one giant results file or lots of little ones?
You get the results back batch by batch or chunk by chunk. They're all associated with the single parent job you submitted.
So I download the results for batch 1, then batch 2, etc.
Correct. You download the result set for each completed chunk individually. Your final step, typically outside of Salesforce, would be to concatenate or combine those files if you need one single dataset for your analysis or loading into another system.
But the key thing is, Salesforce got all the data out successfully, chunk by chunk.
That's the win. It handled the hard part, the reliable extraction at scale. Combining the results afterwards is usually straightforward.
Right, which leads us perfectly into implementation. Section 3. Enabling and controlling the chunks. You mentioned enabling it is simple.
Surprisingly simple, given how powerful it is. You don't check a box in the UI or anything like that. You enable it by adding a specific request header when you create the bulk API job programmatically.
A header in the API call. Yeah. For someone listening who wants to implement this, what's the exact syntax they need?
The key header is force enable PK chunking. You need to include that in your job creation request. And typically, you specify the chunk size there too.
Like how?
So a common example would be force enable PK chunking, chunk size 100,000. This tells Salesforce, yes, use PK chunking and make each chunk contain about 100,000 records.
And 100,000 is the default, right? But I think the sources mentioned a maximum size.
Correct. The default is 100,000 records per chunk if you don't specify otherwise. The maximum allowed size you can set is 250,000 records.
Okay, so why wouldn't I just always use 250,000? Wouldn't that mean fewer chunks, maybe finish faster overall?
Ah, that's a great performance tuning question. You can use 250K, and for simple objects, it often is faster because there's less overhead managing fewer chunks. However, there's a trade-off. If you're querying a very complex object, maybe one with tons of fields, complex formulas that need calculating, or triggers that fire on access, even a 250K chunk might be too much work for the system to handle within the time limits for a single transaction.
So a larger chunk might still time out if the records themselves are really heavy to process.
Exactly. So the general guidance is use 250K for potentially faster throughput on simple standard objects like accounts or contacts, especially if they don't have tons of custom automation. But stick closer to the default 100K if you're dealing with highly complex custom objects or objects with heavy automation, as it's generally safer and more reliable in those cases.
Makes sense. Balance speed against the complexity risk.
Precisely. Choose the size that fits the profile of the object you're querying.
And there's a difference here depending on which bulk API version people are using, isn't there?
Yes, good point. For Bulk API 2.0, which is the more modern version, Salesforce often handles chunking automatically behind the scenes for large queries. It's kind of the default behavior now for scale. But if you're still using the older Bulk API 1.0, maybe for legacy integrations or specific reasons, you must explicitly include that Force-enabled PK chunking header. It won't happen automatically in 1.0.
It's a critical difference for anyone maintaining older code. Now, what about flexibility? Let's say I have that huge 50 million record job. It runs for hours, processes the first 20 million records successfully across, say, 200 chunks, but then chunk 201 fails for some reason. Do I have to start the whole thing over?
No, thankfully. And this is crucial for reliability with massive jobs. You have control over where the chunking process starts. If a job fails midway, you don't need to re-extract the data you already have.
How do you control that?
You use another parameter within that same header, start row. You provide the record ID where you want the next chunk to begin.
So if chunk 200 finished successfully with record ID XYZ, I find the next record ID, ABC, and tell the job to start there.
Exactly. You provide the ID of the first record you want to include in the new job run. Salesforce will then calculate its chunks starting from that specific record ID onwards.
Can you give us a cool example header using both a max chunk size and a starting ID?
Sure, it would look something like this. Force enable PK chunking. Chunk size 200,000,000,000,000,000,000,000
Okay, reading that. Enable PK chunking, use the max size of 250,000 records per chunk, and crucially, begin the first chunk of this job run, starting with record ID 0000000xeftmgh. Looks like the long version. Does it matter if you use the 15-character ID versus the 18-character ID for that start row?
No, absolutely critical point. You must use the full case-sensitive 18-character ID for the start row parameter.
Not the 15-character one.
No. Using the 15-character ID can lead to errors or, worse, incorrect starting points because of case sensitivity issues. Always use the full 18-character ID to be safe and ensure accuracy.
Okay, 18-character ID for start row. Got it. That level of control, being able to restart, really changes the game for massive extracts. It moves it from all or nothing to recoverable.
It really does. It adds that layer of operational safety.
So let's make this concrete. Final section. Real-world impact and business value. Can you walk us through that aha moment using a practical example?
Let's stick with that scenario. Extracting 50 million account records. Maybe you need them in your data warehouse, right? For BI reporting, end-of-quarter analysis, something important.
Okay, 50 million accounts. Without PK chunking, we already know that's likely a dead end, timeout city, hours wasted.
Exactly. Huge operational risk, project delays, people waiting for data they can't get reliably. But now you enable PK chunking. Let's say you use the max chunk size.
Yeah.
Chunk size 250,000. That single API request to extract 50 million records. Salesforce automatically transforms it into 200 separate manageable subqueries. 50,250,000 F equals 200. Each chunk of 250K records runs relatively quickly, maybe seconds, maybe a few minutes, depending on complexity.
And you get the results back for each chunk as it completes.
Right. You see the progress. Batch 1 done, download results. Batch 2, download results, and so on. The entire 50 million record extraction finishes predictably, reliably, probably in a fraction of the time it would have taken if it had even finished at all without chunking.
And crucially, without those sudden, unexpected failures halting the whole process.
That's a core value. It's not just faster, it's dependable. That data pipeline stays open even when dealing with enormous scale.
Which means the business intelligence team actually gets their data. The migration project stays on track. It's not just a technical fix. It directly impacts business outcomes.
Absolutely. The downstream effects are significant.
So if we were to sum up the business value maybe into like 4 key pillars for someone listening, what's the real so what of learning and using PK chunking?
Okay, 4 pillars. Good way to frame it. Pillar 1, speed. It just extracts large data sets much faster by parallelizing the work efficiently across those smaller batches.
Makes sense.
Pillar 2, scalability. This is the mechanism that lets Salesforce handle truly huge data volumes, that 10 million record mark and far beyond. It provides the architecture for scale.
Okay, speed, scalability. Third,
Reliability. This is arguably the biggest one. It prevents those catastrophic timeouts. It ensures data jobs complete successfully, which is fundamental for data integrity and operations.
And the fourth pillar.
Control. You're not just blindly running a massive job. You can tune the chunk size for performance versus complexity. And critically, you can use start row to restart jobs, giving you fine-grained control over potentially long-running processes.
Speed, scalability, reliability, and control, all from adding one header to an API call. That's pretty impressive.
It's elegant, really. It ensures that as your org grows, as your data volumes explode, you have a built-in, efficient way to move that data reliably.
Okay, let's quickly recap this deep dive then. PK is primary key, the unique record ID. Chunking is splitting the job. PK chunking uses those IDs to automatically break down massive queries into small, manageable batches.
Making them faster and way more reliable.
And you enable it simply by adding the source-enabled PK chunking header to your bulk API request. You can control the chunk size up to 250,000, but maybe stick near 100,000 for complex objects.
And remember that start row parameter, using the 18-character ID, gives you that crucial ability to resume failed jobs.
Yeah.
Essential for big data.
It really transforms large-scale data handling from a risky gamble into a predictable science.
It's the difference between hoping your extract works and knowing it will. It replaces potential chaos with predictability, which is gold in data architecture.
Absolutely invaluable for anyone working with serious data volumes in Salesforce. Okay, let's wrap up with a final thought for you, the listener, to consider. We've highlighted how relatively simple this configuration is, adding a header. But think about the flip side, the consequences of not using it when you need it.
Those consequences are measured in failed jobs, hours or even days of wasted processing time, project delays, missed deadlines, and significant operational risk. So, the question to leave you with is this. If you are currently struggling with query timeouts, with unreliable large data extracts, how much cumulative time, how much frustration, and frankly, how much business risk are you actually absorbing right now simply by not implementing this straightforward header configuration?
Something to definitely think about. Calculate the cost of inaction.
Exactly. It might be higher than you think.
Food for thought indeed. Thank you for joining us for this deep dive into mastering massive data queries with PK chunking.